the normal curve, and data that's distributed normally will fall along this curve. You guys saw today with SAT scores that in normally distributed data, the mean falls right in the middle. If data really is normally distributed, this mean also serves as the median, where half the data is above it and half the data is below it. This 1 stands for 1 standard deviation above the mean. This 2 stands for 2 standard deviations above the mean. And this 3 stands for 3 standard deviations above the mean. Likewise, -1 stands for 1 standard deviation below the mean. -2 stands for 2 standard deviations below the mean. And of course, -3 means 3 standard deviations below the mean. Now, this normal curve is on your reference sheet, so there's no need to memorize it. You do, though, have to know how to use it. In Part A, we're asked to find what percent of normally distributed data lies 1 standard deviation above the mean. If you go back to your curve, you'll see that from the mean up to 1 standard deviation above the mean is this section in yellow. 19.1% plus 15% is 34.1%. This means that 34.1% of the data values fall between the mean and 1 standard deviation above the mean. Part B asks us what percent of data lies within 3 standard deviations below the mean. If you go back to your normal curve, you see that from the mean to 3 standard deviations below the mean is this entire section here. Now, to figure out this percentage, we could either add 19.1, 15, 9.2, 4.4, 1.7, and 0.5, or we could realize that this is half of the curve. Half of this data is 50% of the data, with the exception of this small 0.01 over here. If half the curve is 50%, and we want to talk about the whole green section, 50% minus 0.1 is 49.9%. You would get the same answer if you again added 19.1, 15.0, 19.2, 4.4, 1.7, and 0.5%. Part C asks us what percent of the data lies within 2 standard deviations of the mean. Unlike before, they didn't specify above or below. The word within 2 standard deviations of the mean means above and below. It's kind of like if I say that you live within 2 miles of the school, you might live 2 miles east, or you might live 2 miles west if you live within 2 miles of our school. If you go back to your curve then, within 2 standard deviations spans from 2 above all the way down from 2 below. It's these percentages in the purple section that we should be adding up. 4.4, 9.2, 15.0, 19.1, and then another 19.1, 15.0, 9.2, and 4.4. If you were wise, you would see that these 2 sections are symmetrical about the mean. So if you find 1/2, you can multiply by 2 to figure out the total. Part D asks us to figure out what percent of the data lies at least 1.5 standard deviations above the mean. If 1.5 is the least that this can be, then we have to look at values that are at least 1.5 above the mean. Here's 1.5. If that's the least it can be, then we're talking about all the data points above. If you add up these percentages, 4.4, 1.7, 0.5, and 0.1, that's how much data lies at least 1.5 above the mean. I hope you're comfortable now with the normal curve. Now let's try to fit some data to it.
Parents are lazy nowadays. They always say kids are lazy, but parents are lazy too. 7, 8, Lunchables. How much time does it take to make lunch? Huh? How much time? Is what you give me? I love Lunchables, by the way. That's beside the point. Make me a real sandwich. Exhibit B. Instant oatmeal. Are you serious? Is it that hard to make oatmeal? Lazy. Lazy, lazy, lazy. I'm gonna tell you about the time my dad was really lazy and I got him back. Revenge is a dish. Best served cold. It's a regular Saturday morning. Me and Jojo were racing our bunk bed. I let him win, you know, 'cause I'm nice like that. Then we started wrestling. I'm the undergetter 'cause I get under people. Flip them down. Knockout for the winner! And they're like, you can't see me. You can't see me. Wrestle! Jojo, we don't wrestle like that.
Zay Zay! Zay Zay! Isaiah D'Angelo Fredericks!
These are my full name. When parents say your full name, you better hurry up. Yes! That money, he's gonna ask me to get something.
Can you hand me the remote?
Where is it? Right here. Are you serious? It was right there. Lazy, 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 I say.
Thank you. Zay Zay!
Yes?
Can you turn the TV off?
Yes?
Thank you.
You're welcome.
Zay Zay!
Yes?
Come here. Can you turn the TV back on?
Okay.
Thank you.
You're welcome.
Can you take my socks off?
Yes. Ew. This is so nasty. I can't even smell it. Look at those crusty feet. One word, pedicure.
Can you give me something to drink?
Yes. After I touched those slave feet, I had it up to here. Revenge. Burp on it, Joe. Ding, ding. Here's your drink, Daddy.
Thank you. You're such a good son. I love you. This tastes a little funny.
I'm official Zay Zay, and that was evil.
Example 1 talks about the hourly salaries of a group of 30 students. It says that they are normally distributed and have a mean of 8.2 or $8.20 and a standard deviation of $1.55. Let's fill out this normal curve and answer the questions that follow. The mean always goes directly in the center. The mean for this data is 8.2. One standard deviation above that would be 8.2 plus $1.55 or $9.75. Two standard deviations above that would be 9.75 plus 155 or $11.30. And another standard deviation above that would be plus another $1.55 or $12.85. Let's do the left-hand side. The mean minus 1 standard deviation, or 820 minus 155, would be $6.65. Minus another 155 would be $5.10. And minus another $1.55 would be $3.55. Let's take a look at what this all means. What percent of students make between $6.65 and $9.75 an hour? Well, if we look at our normal curve, you'll see that between $6.65 and $9.75, we're talking about 1 standard deviation above and below the mean. What percentage is this? Well, 15 plus 19.1 plus 19.1 plus 15 gives us 68.2%. Part B asks us how many students make more than $9.75 an hour. On our curve, we see that $9.75 an hour is located 1 standard deviation above the mean, and the students that make more than that are located up here. We can't figure out how many students that is until we figure out the percentage of students that is. So 9.2 plus 4.4 plus 1.7 plus 0.5 plus 0.1 gives us a total of 15.9%. This question asks us how many students 15.9% represents. Well, if this total sample is 30 students, we can calculate 15.9 or 0.159% of 30 and get 4.77, or about 5 students. Part C asks us what is the probability that a student makes between $5.10 and $6.65 an hour. On our curve, $5.10 is down at 2 standard deviations below the mean, and $6.65 is 1 standard deviation below the mean. Since this entire curve represents all the data, or 100%, we know that 4.4% and 9.2%, or a total of 13.6%, is represented in this green portion. Therefore, there's a 13.6% chance that a random student out of these 30 makes between $5.10 and $6.65 an hour. Part D asks us how many students make between $8.20 and $9.75 an hour. $8.20 is our mean, and $9.75 is 1 standard deviation above. We know that the percentage of students that fall in this purple category are 19.1 plus 15, or 34.1%, but this question asks us how many that is. Again, we can take 34.1% of 30 to figure out how many students this is. You should have arrived at 10 students. Pause the video and try number 1.